So hello everyone, welcome back to the channel. So in this video, we are going to see the third problem of weekly contest 268, that is range frequency queries. So I'll just quickly read the problem statement and then we will see how to approach this problem. So design a data structure to find the frequency of a given value in a given subarray. The frequency of a value in a subarray is the number of occurrences of that value in the subarray. So we have to implement range frequency query class. So there it will be have two function. One is range frequency query that will be receiving the array as the argument, and the second one is the query that will be receiving three input arguments, left, right, and value, and we have to return the frequency of the value in the subarray left to right. Okay. So let's just see the example one to understand this problem more clearly. So we have given this array, and in the first query you can see that the values are 1, 2, and 4. That means the value of left, right is 1 and 2 respectively, and we want to find the occurrences of value 4. So from the index 1 to 2 you can see that the 4 is occurring only one time, so the output is 1. And for the second query you can see that the value of left and right is 0 and 11, and in the whole array you can see that the number of occurrences of value 33 is equal to 2, so that's why the output is 2. Okay, seems good. So in a brute force way, if I tell, what we can do is for every query we will just iterate this whole array from the given left index to right index, and we will just make a one count variable that will count the occurrence of a particular value. But as you can see that the length of array is 10 raised to power 5. That means if n queries are present and if the length of the array is also equal to n, then it will produce an n square solution, and that will give you the TLE error. So we will solve this problem in a optimal way. So let's see the whiteboard to form an approach. So here we have given a array, and we have also given a query, that is from index 2 to 7 we have to calculate the occurrence of value 4. So you can see that from the index 2 to 7 the count of 4 is 3 times, that is it is occurring at position 3, 5, and 6. And for an optimal approach, what we will be doing is we will use a hash map, and we will make the key as the value that we are required to find the occurrence, and the second argument will be an array which will be storing the indexes of the element 4. So it will be storing 3, 5, and 6. Why we are doing that? Because in case of brute force approach, you are traversing this whole subarray from 2 to 7 to count the value. Now, if you store the indexes of a particular value upon which the query is made, it will be in a sorted order. Then we can apply the binary search approach to calculate the occurrence. So, for this example, for the key equal to 4, we have array as our second argument. So what will we do is we will find the lower bound of the left index, that is 2, and you can see that the value 2 is not present in this array, then it will just return the next greater element than 2, that is 3. So lower bound will be pointing here, and for the right index we will calculate the upper bound. So in our case we have to calculate the upper bound of 7. So you can see that 7 is not present in this array, so the upper bound will be pointing at the end of the array. Now we know the position of the lower and upper bound, so we will just calculate the distance between them, and that will be our answer for the query. So in this way we are able to find the solution in log of n time. So it is much better than the brute force way that was requiring O of n time. So let's try to code it and we will see more condition along the way. So let's first try to create a hash map. In C++, we will be using unordered map that will have first argument of int type and second argument of type vector. that will be storing the indexes. So after that we will just fill our hash map. So for that we will just iterate the given array. So mp ari dot pushback I. So after that we will write the query to calculate the lower bound of index left. So it1 equal to lower bound of mp value dot begin and mp value dot end, and we have to calculate it for left index, and similarly for the right index we will do. For right index we will use the upper bound. So now we will place it as right, and after that we will just return it2 minus it1. So let's try to run it. So the answer is matching. Let's try to submit it, and you can see that our answer is accepted. So talking about the time complexity, for the range frequency query function, the time complexity is O of n, as we are iterating whole array and pushing it in our hash map. And for the query function, we know that the lower and upper bound use log n time to calculate. So for query function, the time complexity will be O of log n. And talking about the space complexity will be O of n, as we are using the additional memory for storing the values. So I hope that this approach is clear to you. So if you have any query, comment it down and I will try to resolve it. So let's meet in next video. Till then, stay safe, stay happy, and happy coding.